Please Look Up is recorded at SciTech on Wajak Noongar land. Good evening, everybody. My name is Leon.
And I'm Beth.
And welcome back to Please Look Up, your monthly deep dive into space news.
And commentary.
Recorded at SciTech on Wajak Noongar land.
So, Leon, what's up this evening?
Good one. The night sky for May is all about the stars.
Yeah, I've been trying to look up and see if I can spot any planets, and so far I've had no luck at all.
Yes, they're all up in the morning. That's fine.
How morning is morning?
Look, we're talking about 5 to 6 o'clock in the morning.
Okay, so like dawn, pre-dawn.
Dawn, pre-dawn.
Okay.
Yeah, so if you're out in the morning, pre-dawn, you will see Saturn and Mars out there in the morning. They're not hugely bright, but they are there. Again, you might want to call upon your friend, the Stellarium app, just in case.
Other apps are available, but don't use them. Use Stellarium because it's great and free and open source.
Jupiter and Venus and even Mercury as well, depending on what time of the month you're looking at, they're kind of lost in the glare of the sun.
Right.
And Neptune you can't see without a telescope. Yeah. So Saturn and Mars they're the way to go, but they're out there in the morning morning sky.
And not particularly amazing.
Not amazing. So, they are there, but
May, not the month for planets this year.
No, not really. You can start by looking to the west and you'll find Orion, the hunter up there. Is basically Orion's a symbol of the Australian summer night sky. And he's in the west just after sunset, meaning he'll be gone very, very soon from the sky because summer is obviously gone. We're moving into winter, which is fantastic. Couldn't have come quicker, in my opinion.
And I think the winter sky is ruled by a different constellation.
Oh, you might be right. Because, yes, what you can do, of course, is you can watch Orion set in the west and spin around and look to the east. And what constellation will you see rising in the east?
The Scorpion.
Yes, the Scorpion. And I was out the other night and I saw the Scorpius in the east at about 9 p.m. onwards. You'll see it. It's a very distinctive constellation. I think we mentioned it in a previous podcast, like a hook-shaped pattern of stars.
Yeah.
And the red Antares marking the heart of the Scorpion.
I was about to say, I can't remember if we've spoken about this before. Is it Scorpio or Scorpius?
I think I prefer calling it Scorpius. I think Scorpio is more closely associated with the astrology and the woo-woo, like this will change your life kind of thing.
Yeah.
I don't think there's a hard and fast rule about it, but I've always called it Scorpius for that reason. So Orion and Scorpius on either sides of the sky, and of course the great story where they're chasing each other across the sky. The Scorpion sent down to punish Orion, and because he was so boastful and said he would hunt everything, all of that, and the hunter became the hunted, and that's why they're at opposite sides of the sky. There's a couple of other constellations, sort of lesser known, that you can see. There's a really, really large, in fact, the largest constellation of all of them is right above our heads at the moment. It's called Hydra, which is a snake, and there's many stories about the Hydra. Cut off its head and 2 more grow back and things like that.
Yeah, I've always been disappointed that the Hydra in the sky is more of a snake and less of the many-headed dragon that's often represented in media.
Yeah.
But I guess that just sort of says something about the origin stories is that they change so much over time that things can become convoluted, and depending on how something's first represented, that can affect how it's perceived for the rest of time, or until a more influential piece of media comes along.
Yes. So what you're saying is first impressions matter.
They do.
They do, yes. Now, Hydra is quite a faint constellation. It's there, but you're probably going to need an app to see it exactly. I always recommend Stellarium because it's free.
And we're still not sponsored by them.
No.
Because they don't have any money, because they're great and they're completely free.
Yes, exactly. Hydra's up there as well. Corvus is another one. Corvus is a crow, and it's just next to Hydra. And it's quite a distinctive pattern. That one's a bit brighter. Again, use an app to see it so you know what you're looking for, but it's a very easy constellation to spot, and it's quite bright, so that one's a bit easier to see. So
if I've found Scorpius, where would I look for Hydra and Corvus?
So if you suppose you stand with Scorpius on your left.
Yep.
Hydra is probably going to be almost straight above you.
So if Scorpius is on my left, Orion would have set to my right.
Yep.
I'll be looking southish,
yes.
So Southern Cross would be up ahead, and then sort of behind the Southern Cross, I guess, would be...
to the top left of the Southern Cross.
Okay, cool.
Would be where you find Hydra.
Awesome.
Yeah, roughly speaking, of course. But yes, and it'll be like that. the night sky changes, but not that quickly. And so this will be up for another couple of months. So if you're, I'm well aware we're recording this quite late into the month of May. But it doesn't matter. You'll be able to see it into June and July. It'll be totally fine. So that's the cool stars you can look at this month. I want to also draw your attention to the moon.
The moon?
Yes, the moon, Earth's moon, which is, there's a very exciting but also really unexciting thing about it this month, is I've decided to call it a blue last quarter moon.
What? So first off blue moon, then blue last quarter moon?
Yeah, so you've heard of a blue moon.
I have.
Yes, do you know, would you like to remind our listeners, what is a blue moon?
So a blue moon, I would hope that I look up at the sky and the moon is blue, but it's not that. It's the second full moon in a month, which is where the phrase once in a blue moon comes from, because it's fairly rare to have 2 blue moons in a month, because months originally come from lunar cycles. That's why they're called months. It's from months, which is fun.
Very cool.
So yeah, having 2 of them in a month is rare, but does happen occasionally. So that's when a blue moon is.
That's right.
Last quarter blue moon?
That's right, because blue moon, the phrase, refers specifically to a full moon, having 2 full moons in a month.
Right.
The month of May does not have 2 full moons this year, but it does have 2 last quarter moons, which is, the last cycle, when the moon looks like a half a disc in the sky.
So it's a blue half moon.
Yes, it's a blue half moon. Except no, and the interesting thing is that they happen just as often, or perhaps just as rarely, as a full moon, but because it's not as visually spectacular as a full moon, they don't get any notice. But yes, the May the 1st was a last quarter moon, and May the 31st will be a last quarter moon. So we'll have 2 last quarter moons in the month of May in 2024.
In the month of May in 2024, we have had 1 full moon.
That's right, we will only have 1. But we've had 1 last quarter moon, and we will also have another one on the last day of the month.
I think we need to pick a different colour.
Yeah.
Rather than it being a blue last quarter moon, I think we should call it like a green moon or something instead.
Well, as you said, the moon doesn't actually change colour. The blue is the phrase used to refer to the fact that we have 2 of that phase in the month.
Yeah.
And I just thought it would be nice to draw attention to the last quarter moon.
Give a little bit of love to a different lunar phase.
Yeah, that's right. And the last quarter moon rises at midnight.
Oh.
So if you're up So if you're up after midnight, the best time to actually see it is in the morning.
Yes.
Because it's up from midnight till midday. So
okay.
Yeah, you might be better off actually seeing it, ironically, on the 1st of June in the morning, unless you're a night owl. So you're either up very late or very early, and you'll see this blue last quarter moon of May.
Which, again, I guess makes the stargazing even better, because you're not going to have moonlight interrupting your stargazing.
Yes, if you're out before midnight.
Yeah. So we can see stars. We can't see planets. We can see a very particular moon. Is there anything else going on in the night sky this month?
Well, one thing you can keep an eye out for, and it's not just unique to this month, it's actually every month, all the time, but you can look out for satellites, and the easiest one to see is the International Space Station, because it's the brightest. And there's numerous websites devoted to it. You can look at NASA's website, which is called Spot the Station. You just plug in your location and away you go. And one thing that's quite interesting actually is I was out looking at the ISS the other day as it flew overhead. This was on the 6th of May when this happened.
Yep.
And it passed over Perth City. And one thing that was really interesting is it looks like this solid, bright, white light moving across the sky.
Yeah.
And most of the time it's quite satisfying. You can see it. It appears over the horizon, flies somewhat overhead, and then disappears over the opposite horizon and then fades away into nothingness.
Yeah, so like a whole arc across the sky.
That's right. If you took a time lapse, you would see this beautiful arc across the sky. 100% right. However, the other night when I was looking at it, it got halfway across the sky and then just like disappeared in the middle of the sky.
Did the ISS get abducted by aliens?
No, but it did remind me, and it elucidates the fact that when you see a satellite, the ISS included, you're not actually seeing light coming from that satellite. I mean, there are lights on board the space station, but they're way too faint. The space station's more than 400 kilometres away above our heads. So you can't even see, the lights on board you can't see from that far away.
Yeah.
What you're actually seeing when you see a satellite is reflected sunlight.
Oh, just like planets.
Yes, that's right. Yeah. But the interesting thing about satellite is because like the International Space Station, it's in low Earth orbit. It's actually quite close to Earth.
Yeah.
And so it can quite easily move into Earth's shadow and get blocked by the Earth, and it's no longer reflecting sunlight. And this is what happened the other night. The ISS was moving across, and it was just the right time of the evening for me to see part of it as it moved across the sky, part of its trajectory, but that trajectory then continued into Earth's shadow, and it was no longer in the sunlight, and it just disappeared.
See, I think I saw the same thing, but because of it being the 6th, I thought it was a meteor.
Oh, right.
Because I just caught it like out of the corner of my eye. I just saw like a flash of light moving across the sky. And yeah, the ISS, I'm used to it going in nice full big arcs. And it's only if it's like interrupted. Yeah, I wouldn't expect that from the ISS. I would expect a short burst from something like a meteor. And on the 6th, there was meant to be a meteor shower.
There was, that's right. Funny you should mention. There was on it sort of peaked about the 5th and the 6th. Yeah, there was a meteor shower called the Eta Aquarids. Nice segue, actually.
Thank you. It was intentional.
It was intentional.
I don't have it. I've got really short hair. I can't flip it, but I did.
Yes. Yeah, a meteor shower was occurring. However, the interesting thing, that the best time to see that was in the morning. Hopefully some of you got out and had a look at it.
Well, that's why I was confused, because I was like, it's nighttime because I am an owl, not a lark. Yeah. So, yeah, I was like, wait, I thought that they were meant to be in the morning. Oh, yeah. Well, it must just be a rogue one.
Yeah, rogue one. They're better after midnight, but they're not impossible before the evening. Yeah, they're really interesting. Yeah, the Eta Aquarids meteor shower. Their meteor showers themselves are quite interesting because it's actually very difficult to know exactly when you'll see one individual meteor. So a meteor, they're little specks of dust, and as they move through Earth's atmosphere, they light up as they lose their energy. But it's quite easy to know when a meteor shower will occur because meteor showers occur when Earth plows through a dust cloud in front of its orbit. So I like the analogy I keep going back to is the bug on the windscreen.
Yes.
You're driving through a swarm of bugs and they keep splattering across the windscreen.
Yeah.
As Earth sweeps through this dust cloud, they splatter across Earth's windscreen.
Yeah.
And because we know where these dust clouds are, Earth passes through those dust clouds at the same time every year.
Yeah, because they're on our orbital path.
Yes, that's right. And what I particularly find interesting about this meteor shower from early May was that dust cloud was made up of residual bits of dust that were blown off from Halley's Comet.
Oh.
So the legendary comet of Halley's fame.
Wow.
Probably hundreds of years ago passed in this direction.
Yeah.
It's nowhere near Earth at the moment, and it's not going to come anywhere near Earth anytime soon.
Yeah.
So yeah, centuries ago, it passed roughly through this region of space, and all of that debris that got sort of ejected off is still there, still orbiting the sun, and Earth swept through it a couple of weeks ago, and that's that might have been what you were seeing as well.
Yeah. Oh, so it might have been a rogue meteor, but it might also have been the International Space Station going into some shade.
Depending on how fast it was, you can probably tell the difference. These meteors from the Eta Aquarids move really fast. They're like visible for less than a second.
Oh.
Whereas when we're talking about the International Space Station moving overhead, that's something that can take 5 to 7 minutes, depending on where the angle and things like that.
Yeah. Right. Awesome.
So, but yes, that happened on May the 5th or May the 6th, thereabouts, just after Star Wars Day.
May the 4th.
Yes, I love it.
May the 4th be with you. Although, May the 5th should also be a Star Wars Day.
Really? I'm not that much of a nerd.
Revenge of the Sith. Revenge of the 5th.
Revenge of the 5th. Yeah. Oh, yeah, of course.
Yeah, it depends which side of the force you do. Anyway, space podcast, not a space fiction podcast. All right, so planet's not amazing for this month. People might have to listen in to find out about next month. And we've spoken a little bit about stars, but Leon, where are my star shapes?
Yeah, I think the coolest constellation this month is a constellation called Vela, the Sail. And if you've been paying attention to the last couple of months, you might have been able to guess that, because Vela is part of the great boat of the sky, the Argo Navis.
It's back its third month in the row.
So 2 months ago we spoke about Carina, the sort of the deck, and last month was Puppis, the back, the poop deck, and then this month is the sail. So a boat. We're talking about a ye olde boat made of wood and a sail. Yeah. And Vela is the sail of the boat in this constellation. Now to see it's out in the sort of southwestern sky. In the evening sky this month.
Yep.
So remember before when I was saying that the Hydra is off to the top left of the Southern Cross.
Yes.
Vela is sort of to the top right.
Okay, cool. So Vela is sort of between the other two, right? It's sort of, they're kind of in a triangle because it's a boat shape.
Yeah, pretty much.
Yeah.
Carina's at one end of the triangle.
Yeah.
Papas is at the other, and Vela is sort of in between, but a little bit offset.
Yeah. So this massive constellation, it used to be all one altogether. But basically we decided that was too complicated.
It was just too big, really.
Yeah, it's too big, too complicated, and so it got split up. According to my notes, because I did research about Vela,
yes.
it was split in the year 1752 by Nicolas Louis Lasalle. I want it to be Lasalle because that is sail because the boat, because he split the boat. But if we have any French listeners, please just don't send me massive hate mail for terrible French pronunciation.
The email address is Beth.
No. So I wanted to talk a little bit more about not just Vela, but the Argo Navis as a trio, because it's got some really interesting and weird sort of like word meanings that we can sort of draw parallels with. So the ship, the Argo Navis, was the ship that Jason and the Argonauts sailed on their big voyage to find the Golden Fleece in Greek mythology.
Yes.
But Argonauts sounds a lot like astronauts.
Mm-hmm.
So that's because the word naut comes from the Greek word for traveller, or sailor in particular. Astro is star, so astronaut means star sailor.
Star sailor.
Which I think is very romantic. I think it's beautiful. Mm-hmm. But yeah, there's just my little aside into etymology in the middle of our space podcast. Sort of zooming back in from the Argo Navis trilogy to Vela, it's like, I think it's most exciting because it's part of this big constellation, which there's a lot of myth stuff around, which I'm a big nerd about. But there's a pulsar in Vela.
Yes, there is.
Leon, what's a pulsar? Please help.
Yeah, pulsar, there's a few layers of groundwork we have to establish here. Mm-hmm. But long story short, a pulsar is a very small, very rapidly spinning star.
Okay.
And to understand how that happens, we kind of need to wind the clock back a bit. Because, pulsars are the late stage of the life of a very, very large, very heavy stars. So
we had a very large, very heavy star, and late in its life it gets really small.
Yes, that's right.
Okay.
Yeah, quite interestingly. We're talking big stars, 10 times heavier than the sun. And
are we talking like red supergiants, like Antares in Scorpio?
Yes. Well, good idea, actually. Yes. yeah, red supergiant stars. So, big, heavy stars that are heavier than the sun. They live their lives furiously fast because of the way stars work, which bit off topic for now. But long story short, when they run out of fuel, they explode. Uh-huh. Most of the star explodes. The outer layers get thrown off into space. But what happens is
that a supernova?
Yeah, in a supernova, which Antares will do one day.
Yeah.
And so the outer layers get thrown off into space, but the core of the star kind of gets crushed underneath the exploding outer layers.
Okay.
And if that explosion is, not too violent, it doesn't get crushed into a black hole. It gets crushed into this really tiny ball of neutrons, which we call a neutron star.
So it's kind of like a choose your own adventure. Like, there's a couple of different paths that a star could take later in its life.
Yes.
One path leads to black hole. One path leads to neutron star.
Yeah, and that path is very, very, very strongly dependent on how heavy the star is in the first place.
Right.
So the sun is not heavy enough for either of those.
No.
It'll just kind of fizzle out and turn into a different type of small star. Again, story for another day. But yeah, many millions of years ago, there was a big star which the core got crushed into a dense ball of neutrons as the outer layers of the star exploded. And the remnants of that is what we call the Vela pulsar.
Right. When does it start spinning?
Well, the star itself is spinning right from the start.
Right.
Imagine, a star is formed from a collapsing cloud of gas, and imagine trying to squeeze a cloud into a small sphere. It's going to, you're going to have off-axis parts of the cloud, which as you squeeze them down, they cause the whole thing to start spinning.
Yeah. Okay, so the spinning is there from the beginning through the whole supernova.
Yep. But then imagine this. So imagine you've got a star, or we'll go back to the analogy of the ice skater.
Yeah.
You know how ice skaters bring their arms in to their chest and they start to spin faster? As this core of the star gets crushed down into a tiny, tiny, tiny little ball, it keeps that spinning momentum, and so it starts to spin a lot faster.
Okay, so
the original core of the star might have been many millions of kilometres across, but then during the supernova, it was crushed down to be something about maybe 20 kilometres wide, so about the size of Perth City.
Oh, that's not very big at all.
No, so imagine squeezing all of the rotational energy or most of the rotational energy of a star into something the size of Perth City. That thing is going to spin very fast.
Oh, yeah.
But not only that, neutron stars or pulsars, which is what this is an example of.
Are they the same thing?
They are the same thing. Well, every pulsar is a neutron star. Not every neutron star is necessarily a pulsar.
Right.
And what does that even mean? What does it mean? Why is it a pulsar?
Yeah.
Because not only that, the stars have magnetic fields as well, and magnetic fields can't just get destroyed. They have to. There's a certain amount of magnetism in the universe, and it has to stay that way. So not only does all of the momentum of the star get squashed down into this little ball, so does all of the magnetic field. It gets squashed down, and so these.
And this is after the explosion. This is not at the explosion point.
No, after the explosion.
It feels like there's going to be another explosion.
You ironically end up with something almost more violent than the explosion itself. Yeah, this extremely dense, extremely magnetic object that spins really, 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 really fast. And the reason it's a pulsar is because the magnetic field is so strong that it can kind of rip electrons off the surface of the star. And as they spiral around the magnetic field, they give off these bursts of radio waves. And then as the star rotates, if that burst of radio waves happens to be pointing at the Earth, we get a burst of radio waves. And it's a bit like a lighthouse. Imagine a lighthouse.
Yeah.
The lighthouse is constantly shining in all directions, but as it rotates and you just see that beacon cross your path,
we see a pulse of light.
We see a pulse of light, and if that happens regularly and repeatably, it's a pulsar.
Cool.
Although pulsars, we tend to see them in the radio spectrum.
I was about to say, so if I'm looking at Vela tonight, I won't be able to see a flashing light in the sky because it's not visible light. But if I was looking with a radio telescope, I would be able to detect a pulse of radio emissions.
That's exactly right.
Cool.
And there are many radio telescopes that have done exactly that and looked at Vela, and we can actually take that radio signal, play it back through a speaker at a frequency our ears can hear, and we can actually hear the sound. Let me remind you, this is the sound of a star spinning.
So we can listen to a star spinning?
Yes.
Can we do it now?
We can, yes. And remember, this star probably weighs about as much as the sun and is the size of Perth City.
Oh my goodness, I'm so excited.
All right, here we go. So every one of those clicks you're hearing is an entire revolution of a star.
Whoa.
So, and astronomers have calculated that's spinning about 11 times per second. So you can do some quick maths. It's 20 kilometres across. Its circumference is probably about 70 kilometres. So the surface of that star is moving around 70 kilometres in about a tenth of a second. That's how fast the surface of the star is moving. It's insanely fast. Hundreds of kilometres per second is the sort of rotational speed of the surface of that star.
It sounds kind of creepy.
It does.
Can we listen again?
Sure. Sounds like something you would DJ to at a festival.
Yeah, I'm torn now between either like creepy alien sci-fi villain or rave.
Yeah.
Or both.
Could be both.
Both.
Now, I got that recording, actually. That's from CSIRO. That was taken by, take a guess.
Was it Skeo?
Not Skeo, the other big one.
Is it The Dish?
The Dish.
The Dish!
The Dish. The Dish recorded that. The Parkes Radio Telescope in New South Wales recorded that one. So thank you, CSIRO and Parkes, for that.
Oh, thank you. And I think that pretty much wraps us up for Constellation of the Month as well.
I think that's a good way to go out on a bang.
Is it a bang though, or is it a pulse?
A pulse.
We can go out on a pulse.
I was about to say go out on a big bang, but that's not a big bang.
That's a whole other thing. Space is just series of concentric circles.
It is. It's just like an onion.
So, you can't talk about space without talking about all the stuff people have tried to put there. So, Leon, what have we been trying to put in space this month?
Yeah, funny you should ask. As of this recording, like literally a couple of hours ago.
Oh, really?
One thing that we've been trying to put in space for a while is the Boeing starliner. And I know Boeing is kind of cursed at the moment, and this just seems to be an example of that.
Oh no!
So the Boeing starliner is a crew capsule. It's to put human beings in space on top of a rocket, send them at the moment to the International Space Station, and they've been trying to do that for a while, and they were supposed to actually launch a crewed test tomorrow morning.
So this is Boeing's crack at the space shuttle.
Yeah, not so much a shuttle in the sense that the shuttle had its own engines and launch system,
Right.
whereas the Starliner is a capsule. It's about the size of a small room to carry, at the moment 4, but eventually up to 7 people at once. But it sits on top of a rocket that somebody else builds. So somebody else builds a rocket, but Boeing built the capsule.
Okay.
And the capsule, the rocket doesn't get to space. The rocket just gets off the ground, but the capsule goes to space, carries the people to the space station, and then at the end of the mission, they get back in the capsule and they come back to Earth.
Right.
And then the capsule gets, reused and so on.
Cool.
Yeah. So, and it's a competitor to SpaceX.
Okay.
SpaceX have their own Dragon capsule, as they call it,
Yeah.
and it launches on a SpaceX rocket, and
Right.
it's been operating for a couple of years now. Boeing, this poor capsule, this poor Starliner is just kind of cursed. It was supposed to launch tomorrow, but a few hours ago, this is, as of this recording, it was supposed to launch on Friday the 17th of May, but they had to cancel the launch because they discovered a helium leak.
No.
It's not a big problem. It's a helium leak that pressurizes one of the engines on the capsule. So in space, where there's no gravity, fuel doesn't fall down into the engines. You need to push it into the engines.
Okay.
And to do that, you use helium. You open a helium tank and the helium flows out and it pushes the fuel in the other direction and the fuel
Just
goes into the engine.
Pressure.
Yeah.
Okay.
But one of those, they had a helium leak, so they had to call the launch off. But, it was supposed to launch actually a couple of weeks ago, but they discovered another problem.
Oh.
But this time the problem was not with the capsule, it was with the rocket.
Okay. So it wasn't Starliner's fault?
It wasn't Starliner's fault.
Okay.
Not last week. It was
this
today.
week? Yeah. Okay.
Yeah, last week they had a problem with an oxygen valve on the rocket. The rocket
goodness.
itself, that there was another pipeline that, there was a valve supposed to vent excess oxygen, and the valve kept, malfunctioning and opening and closing when it wasn't supposed to.
I mean, I guess when you've got like millions and millions of moving parts, I would much rather discover one of them had something wrong with it while we were still on Earth.
Yes, that's right. But yeah, funny you should mention. So this is the first crewed flight of Starliner, and hopefully it'll launch soon.
I guess it hopefully doesn't take too long to fix a helium leak.
No, they reckon a couple of days.
Yeah.
But it's going to carry 2 astronauts, Butch Wilmore and Suni Williams, to the International Space Station for about a week is the sort of plan. But as I said, it's their first crewed flight. They've done 2 uncrewed flights.
Okay.
One of them was in 2019, and that one was actually almost catastrophic.
Oh, goodness.
Yeah, after it launched, and only after it launched, and it was in space, did they discover 2 very major problems that could have almost caused a loss of mission.
Well, that's why we send them unmanned first.
Yes, that's exactly right. And yeah, it turned out the clock on board was off by 11 hours, and so it thought it was on a different time of day, and it's like, oh, time to fire the engines, and burnt through most of its fuel at the completely wrong time. They were able to recover it and bring it back to Earth. It didn't dock with the space station. They ended up discovering a number of problems after they got back. And then they did another test flight in 2022, which was mostly successful. Couple of problems with it. There was a couple of engines didn't fire properly, but they weren't critical to success. So
see, that's the kind of problem I expect from a rocket launch. Like, rocket science, like engines not firing on all cylinders properly. Something's gone wrong with the flibber-hibber machine. Not the clock was wrong.
Yeah, it was a software error.
Oh my goodness.
Yeah, which is exactly, and quite a big oversight, but has since been fixed. And so it's interesting. Everyone's a bit cynical about Boeing right now, and especially about Boeing Starliner, because it's very overdue and very over budget. Yeah. But it's kind of NASA needs an alternative, because at the moment all the eggs are in the SpaceX basket. Yeah. And suppose something goes wrong. Yeah. Hasn't been any problems with it yet, but then the only other option is, at the moment, to get to the space station is Russia, and the USA and Russia are getting along famously well at the moment.
Oh yeah, as well. Well, they haven't always historically been best friends, have they? So
there is a rideshare agreement. There are on the space station, they always want to have at least one US astronaut and one Russian astronaut, because the space station is largely, not entirely, but a lot of it is built by USA and
Yeah.
Russia.
It's
And so-
neutral ground.
Yes, it is. And obviously there are international contributions too, but they always
Yes.
want to have one on each. So at the moment there's a ride-sharing agreement where cosmonauts will launch on American rockets and astronauts will launch on Russian rockets.
Yeah.
But you can imagine how pleased Russia will be if a whole crew of NASA astronauts has to launch on a Russian rocket.
Yes.
So yeah, NASA really does need a backup for the SpaceX Dragon.
Yeah.
And the Boeing Starliner is their backup.
Yeah.
And so this is its opportunity to prove itself in this flight test. Problem is, it's right down to the wire, and it's still having trouble.
Yeah.
But again, not all of that is at the moment. Not all of that is Starliner's problem.
No, but I imagine that there's a few groups of people I imagine who are looking at this fairly happily, and that would be the Russians and SpaceX going
100%.
like, yeah,
Yeah.
fail Starliner.
Yeah, exactly.
So, like we said with Starliner, things go wrong, right?
Occasionally.
Yeah. So, I think that we're going to bring back a little segment that we tried a couple months ago, which is Space Fail of the Month. Space Fail of the Month is where we talk about things that failed in space. So we had Starliner, which luckily didn't fail in space, failed pre-space. What else has been going wrong there, Leon?
Well, I would call this something that went wrong for a long time and has finally started going right again. But that is Voyager 1, which is a spacecraft.
Yep.
Tell me about Voyager 1.
Well, Voyager 1 was launched in the 60s?
70s.
70s. So it's been going a little while. The Voyager missions, Voyager 1 and 2, were sent out beyond our solar system. And I don't think that I'm not sure if it was ever intentional that they would actually still be working past the year 2020. But they've been doing a pretty good job of collecting data, sending data back to us. But they're also sort of our Earth-based message to the universe. So they've got on board both Voyager 1 and 2 the Golden Records, which are not a vinyl record, but a gold-plated copper vinyl style record with
You drag a needle on it.
Yeah, you drag a needle along it, and hopefully aliens will be able to read it and get some information off it. So it's got examples of Earth biology, it's got human speech samples, it's got music, so it's got cultural examples as well on it. I know there was a problem at one point where someone pressed a button and we lost contact with one of the Voyager spacecraft.
Yes, that was Voyager 2 that was accidentally pointed away from Earth for a second.
Yeah.
We eventually got it back.
And also, when Leon says we got it back, he means Australia. So,
Yeah.
we're pretty important when it comes to space.
Yes. But yes, no, I'm
So
actually talking
what's
about...
going on with the other one?
Yeah, Voyager 1's had some problems. So yes, to quickly recap what you said, Voyager 1 and 2 were both launched in 1977, and Voyager 1 visited Jupiter and Saturn, and Voyager 2 visited Jupiter, Saturn, Uranus and Neptune.
Ooh.
And to date is the only spacecraft to have ever visited Uranus and Neptune. And then off they went. Once they finished, they didn't stop there. Spacecraft don't have brakes. They kept going, and they just flew past, and they've been going out ever since. And they still work somehow. In fact, engineers at NASA have slowly been turning off bits and pieces of them to conserve what little power they still have.
Right.
But yeah, late last year, Voyager 1 started sending garbage data back to Earth. But it was sending garbage data in such a way that they knew the spacecraft was still working, but there was something wrong with the data. Something was happening to the data between getting collected and then sent back to Earth. So they could still send signals and receive signals. So it wasn't that the whole thing had just stopped working.
Right.
Just the data was all garbage.
Right. So it's like, I'm reading a book, the book is fine, it gets into my eyes just fine, and then my brain's like, this makes no sense.
Yeah, pretty much.
Okay.
Yeah. And to push that analogy further, there was something wrong with Voyager's brain. They figured.
Yeah.
They're eventually able to track it down. So this took quite a long time because this is the thing to remember from a spacecraft launched in the 1970s. Is all the original people who built and worked on it have long since retired and moved on.
Yes.
So this new generation of engineers have to retro engineer, hand-drawn diagrams and things like that.
Well, I guess even the code will be like, it would be like trying to read Aramaic, like just a language that doesn't exist anymore.
That's right. And so it took them a very long time to figure out that what had happened was that one of the chips on one of the computers on Voyager had stopped working, and this this computer was in charge of taking the data off the science instruments and packaging it in a way that could then be sent back to Earth.
Right.
And this little chip stored a piece of code that was important to preparing that data.
Yes.
And because the chip stopped working, for reasons they don't know, it just stopped working.
I mean, again,
old age.
It's getting on a bit for a chip
could have
in
been
space.
hit by a cosmic ray or something like that.
Yeah.
High energy particle from space. Long story short, the chip stopped working, so the computer couldn't draw the code off the chip, and so therefore it had bad code. And then when you feed good data to bad code, garbage in, garbage out.
Right.
And so we got rubbish back at Earth.
Is that something where we could put the code in on Earth instead, or?
No, because it was the rest of the processing had to take place on Voyager.
Right.
So what they did, however, was they were clever enough to figure out the code that was, compromised,
Right.
and break it up and save it on other parts of where else there was memory on the chips of what was still working on Voyager.
That's so cool.
And then, of course, they had to update the rest of Voyager so that when it ran this program to package the data, instead of reaching for the code over here in the old broken chip, it would reach over here for part of the new code and over there for the other half and
my
over here
goodness.
for the last little quarter, put it all back together, process the data and send it off to Earth. And, hiding that code on the remaining parts of the spacecraft is really quite impressive, because the thing about spacecraft is there is no room for...
No, they don't build in extra, just like, we'll put some extra memory in here just in case. Like, that's not how it works.
That's right. Exercises in minimalism.
Yeah.
And they were able to do that. And they've managed to get engineering data back. They've still got to figure out how to get science data, but they can get things like, readouts of the performance of the spacecraft are still working.
I guess all of this as well. How far away is Voyager 1 now?
Oh, it's I think it's about 20 billion kilometres.
So we're talking light minutes still?
Yeah, well, speed of light's about 1 billion kilometres an hour, just over. So we're talking about 20 light hours. So it takes almost 2 days. So almost a day for a signal to get from Earth to Voyager, and another day to come back again.
So all of this like code troubleshooting and everything, through all of it, it takes an hour to get there. No, a day to get there and a day to get back as well. So that's also partly, I guess, why it's taken so long, is because we're just trying to send code.
Yeah, it's pretty nuts, isn't it?
Could you imagine waiting? And I mean, I'm sure that several people who lived while the internet was young can imagine, but can you imagine waiting a day to download a podcast?
Your video is buffering and you have to wait like 10 seconds, and it's so frustrating.
Yeah.
Imagine that, only to find that your code didn't work.
Oh my goodness. That would be so frustrating.
We've just managed to find here a data source here.
Oh.
A piece of information. The computer on board the Voyager has a total memory of 69.6 kilobytes. So
Kilobytes?
Kilobytes, not megabytes or gigabytes. The computer in front of us in this room here has probably 1.5 terabytes of memory, 69 kilobytes.
I have seen a 2 terabyte hard drive that can fit in the palm of my hand just now.
Yes. So we're talking minuscule amounts of memory.
Right.
Here.
So not only do modern coders have to work out how to interact with old code, they also have to work out how to interact with old volumes of memory.
Yes, that's right. Yeah.
No excess.
No excess. Yeah, that's right. There's literally not a case of if you shout loud enough at your manager, they'll let it go. It's like,
no.
It doesn't matter. It's not going to work if it doesn't fit on that.
Yeah.
So you're working with very, very limited memory.
So I imagine that's also why they couldn't just put the whole bit of code onto another chip, because there's not room for the whole bit of code on any of the other chips.
Yeah.
Wow, that's absolutely incredible.
So they've still got work to do. They've got to get the science data back as well, and that'll just be more troubleshooting and cleverly stuffing code in other places. Reminds me of remember the Mr. Bean episode where he accidentally orders a steak tartare?
Oh, yeah.
He starts hiding meat all over the place.
So we've got to hide some code meat in various places in this space restaurant.
That's right.
So that's kind of it's
eventually a space success.
It's a space in the process of unfailing, I guess.
Yeah, exactly.
We're not 100% yet, but what we've done is impressive.
Yes, and it's a testament to human creativity and problem solving as well.
Yeah, absolutely. Yeah. Which I think is one of those amazing things about the space industry and about space innovation, is that it is really one of those places where human innovation and problem solving is showcased so brilliantly.
Definitely.
So, I have a new segment for us today. It's hardly even a segment, it is more of a snippet. Space has a lot of confusing vocab, and very niche terminology, so I wanted to give a tiny bit of clarification to some of that every once in a while. So it's going to be like a dictionary of space terms.
Space dictionary.
Yes. But because alliteration is fun, I thought instead of calling it Space Dictionary, we could call it Deep Sky Dictionary.
Ooh, okay. So it just rolls off the tongue.
Yeah. Unless any listeners have any better suggestions, I did make a terrible list on OneNote document that Leon has been laughing at me about. So if anyone can come up with anything better than Deep Sky Dictionary, let us know.
Just crashed.
Oh no.
I can't even read them out.
That's how terrible this list is. OneNote crashed. But for now, for our Deep Sky Dictionary, word of today, gibbous.
Gibbous, yes, a word I'm quite familiar with.
Gibbous. Gibbous is a word that you might hear in relation to the moon. Now, in that context, it's the opposite of a crescent. It's not quite full, but it is over halfway, so it's convex at both edges. Now, the word gibbous comes from the Latin for hump, and it can be used to describe other round things. Google suggests that you might want to use gibbous in a sentence like this, and this is a direct quote: "The gibbous belly of a sleeping kitten." Nice round thing. So when you see a gibbous moon, now you can think of a kitten's little tummy. You're very welcome.
I mean, that's quite an attention-grabbing visual, isn't it?
Yeah, little round white tum of a kitten, little round white moon.
Yeah, there you go. I mean, yeah, I quite casually throw around the term gibbous moon without even stopping to think if people actually even knew what I was talking about.
Yeah, I had no idea. But now I know. Now every time anyone says gibbous moon, I will be able to remember it's like a kitten's tummy.
Kitten's tummy. There you go.
So, talking of good visuals, do you have a photo for me, Leon?
I do.
Because I've got a photo for you.
I had almost forgotten this.
It's Space Photo of the Month.
Space Photo of the Month. All right. Well, would you like to go first? Would you like to send me your photo?
I've already sent you my photo.
Oh, you did?
Because I've been on a little bit of an adventure recently. So we're recording this from SciTech, and as part of the team I'm on at SciTech, one of the things that we get to do is travel around the lovely state of Western Australia. And I went somewhere quite interesting and space-related, and I sent Leon a picture from that place as a taunt to see if he could work out where I was, and he couldn't. So I refused to tell him until I got back and we recorded this podcast. So, Leon, have you found the picture?
Right, I can see. I mean, it looks like a radio telescope, but it looks like a very strange one. So I want you to all imagine that sort of stereotypical big metal dish that points up at the sky. Mm-hmm. That's kind of what it looks like. However, it's not nice and pleasingly circular. It's more of a square shape, and it looks to be about maybe 10 metres tall. So it's got a concrete base, sort of a roughly triangular concrete base, and then on top of it is the dish, but the dish is square, and it looks to be about maybe 8 to 10 metres across, and it's very ugly. There's lots of metal pieces hanging off all the sides. There's lots of rigging, and there's a few cables holding it down. So yeah, it looks like an ugly cousin of those glorious dishes that you're used to seeing, and it's square. I would love to know what this is.
Yeah, it's hideous. You are correct. It is a radio antenna, actually.
Yes, actually.
This is at Carnarvon Space and Technology Museum.
Oh, I was there just last year.
You were, which was really funny when I sent you this picture and you said, I have no idea where that is. And then I spoke to one of the staff later and was like, oh, you're from site. Oh, was Leon there? And I was like, oh, he does know where I am.
Oh, there you go. We must have, to be fair, I went there at night time and went straight to the lecture hall to give a talk. So we got a nice photo of the big one, the real big one, the tracking station, but not this one.
No, so this is known as the Sugar Scoop antenna. And all of this information is from the Carnarvon Space and Technology Museum, so full credit to them because I had no idea what it was, which is partly why I took a photo of it to send to Leon, because I was like, this is weird, because I haven't seen one of these before. So it's called the Sugar Scoop because of its shape. So yeah, most antenna you would expect to be sort of nice and dish-shaped, but this, it's got a 42-foot aperture, and it's called, and this is ridiculous, it's called A Cassegrain-fed folded horn antenna.
Some of those words do make sense. There are designs of telescopes, Cassegrain, however.
Yeah.
It refers to the way it collects light, yes.
Yeah, but all of it sounds like to me is that it's a farm. Because it's like a grain-fed folded horn. And I'm like, that sounds like a cow. But no, apparently this is space. So it was actually unintentionally the first antenna in Australia to test links to the UK in 1966. So it's pretty old. So it was used for the first live satellite TV broadcast in Australia as well, which was Down Under Comes Up Live. So sort of it was communicating with a satellite in 1967. And then it later was used as part of a satellite relay station in support of NASA's Carnarvon tracking station. It became famous again, so it had a little spike of popularity in 1966, and then again in 1967, and then it became famous on the 21st of July, 1969.
1969. I wonder what happened then.
What happened then? Well, that was the day of the Apollo 11 moon landing, so it was part of the system that relayed Neil Armstrong's first steps on the moon from NASA's Honeysuckle Creek tracking station in Canberra to Perth's TV audience. So it is the antenna that helped broadcast the moon landings to Perth. And it looks like a sugar scoop and is completely hideous. But the reason, I was like, why have I not seen this before? This particular one that is still standing in Carnarvon, it's not still functional, it's not still used, but it is thought to be the only one of its kind remaining in the world. So that's why you wouldn't have seen it before. It's pretty unique. Wow. And just in little Carnarvon.
That's fascinating.
Yeah.
Yeah, the Carnarvon Space Museum up there is fantastic. It's a beautiful place.
So good. It was definitely worth going. It's also one of very few places with a full-sized replica of the Apollo 11 moon lander. Yes. Because it was made by a few of the staff there.
Yes. One of whom used to work right here at SciTech.
Absolutely. We may have met, we may have had a chat.
Denham's great, isn't he?
Yeah, it was amazing. So yeah, can highly recommend, if anyone is in the area, visiting the Carnarvon Space and Technology Museum. It's entirely run by volunteers. They didn't ask me to plug this at all, but I think that it's worth doing, supporting Western Australian space innovation. And also then you get to look at some pretty cool, awesome, giant-looking dishes and one hideous but beautiful sugar scoop antenna.
Mm-hmm. Yes, hideous but beautiful is quite a nice description.
Yeah.
Beauty is in the eye of the beholder.
Yeah.
And now that you've given it that backstory, that really is, that's a piece of history right there,
yeah,
isn't it?
Yeah, it's incredible. But when you look at it, you're like, why is this block of beige
Concrete
cheese on the side of this hill?
Well, that's it for this episode of Please Look Up. It's been a time and a half like it always is. Thank you so much, Beth.
Thank you, Leon.
And thank you for listening. We'll see you next month.
This is a Particle Podcast. WA Science told different. Powered by SciTech.